Hello everyone. In this session, we are going to see the topic called searching in data structures and algorithms. For example, if you take a dictionary, you are searching for a word. Then how do you search? We will search by different ways from one person to another person. Likewise, if you go to YouTube and then if you search for a videos, we will search for the videos by different terms or by different ways. Likewise, in the world of programming, the searching is the very much basic operation. So now the searching can be performed by different ways. In this video, we will see about how can we search by means of using a linear search or binary search or jump or interpolation. So there are many types of searching algorithms are there. So these are the basic algorithms: linear, binary, and then jump, and then interpolation. A linear search. The linear search is a very basic and simple algorithm where you can apply it for an unsorted array. So your input cannot not need not to be an sorted, it can be unsorted. So what it will do? It will go and search by one. For example, in the list of registration numbers from 1 to 100, I need to find an registration number called 51. Then I'll compare with the first registration number with the 51, second with 51, third with 51. Likewise, linearly, I will go for one by one and compare it. And if I found the data, then I will give the success. If not, failed. So here example you can see. So in the unsorted array, this is an unsorted array. In the unsorted array, I am searching for the element called 20. Then what do? I will go by linear search. That means that at first I'll compare the 20 with 10. So it is not there. So I'll go with 20 with 50 and 20 with 30 and 20 with 70, 20 with 80, 20 with 60 and 20 with 20. So when 20 with 20 arrives, then the key which I want to search, which I am searching for, I have found it. So that will be shown in the output side. This is called an linear search. It will go by linearly one by one search. The best case, if 20 is in the first position itself, then I will get the data with a fraction of first comparison itself. So the best case is going to be order of 1 and the worst case is going to be an order of n. Suppose if 20 is in the last, then I have to compare all the data one by one. At last, I will find the data. So the worst case is going to be order of n and the best case is going to be order of 1. So now here, what's the algorithm for the linear search? So I will search for the first element, start from the first element and compare each element with the target. So here the target is 20 and I'll start from the first element onwards, 10 with 20. So until match found, I'll be keep on searching for the data. So the corresponding pseudocode. So for I is equal to 0 and then I less than n, I plus plus. So here I want to search. For example, the key is the corresponding the element which I want to search. I'm searching for the 20. So if array of I is equal to key, then I will return the data. Okay, where it is, the index value. So if not, I'll be keep on incrementing the I. I is equal to 0. Array of 0 is equal to 20? No. Array of then increment I. Array of 1 is equal to 20? No. Array of 3 is equal to 20? No. Array of 4 is equal to 20? No. So likewise, I'll be keep on going for linear search. So then what happens over here? Array of 0 is equal to 20? No. Array of 1 is equal to 20. Array of 2 is equal to 20. 3, 4, 5, 6. So now what happens over here? So once array of 6 is equal to 20, then this becomes true. Then I will return the I. So I is equal to 6. So in the sixth index, the element is present over there. So this is called linear search. Next, we will go for a binary search. So binary search, what we are going to do, we are going to divide the unsorted elements. So for example, you can see here, this is the element. So always in the linear search, we will get the input as an unsorted array, but here it should be in sorted array. It should be in sorted array. That's a difference. In linear search, you can take an unsorted array, but in binary search, always you have to take an sorted array. You can see here 2, 5, 8, 12, 16 until 91. Everything is sorted out. So now what do I do? So now L is equal to 0 and H is equal to 0. I'll find the median value. I'll find the median value. So then M is equal to 4. So I'm searching for 23. So now at first I'll compare the 23 with 16. So now 23 is with 16, right? 23 is very much larger than the 16. That means that the data which I'm searching for is after the index 4, the right side of the index 4. So now what happens over here? I will change my L is equal to 0 to the L is equal to 5. That means already the 16 has been compared. So L becomes M plus 1. So L is equal to 5. So now from 5 to 9, I will find the median value. I will find the median value. So now here M is equal to 7 is the median value. So now what happens over here? So 56, which I am searching for is 23. 23 is lesser than the 23 is greater than the 56. That means that the element which I'm searching for is in the left of the 56. So now what do we do here? I will change the h is equal to 9 to the m minus 1. So it becomes h is equal to 6. So now there are two elements are there. So in the two elements, I'll find the median value, m is equal to 5. Then I'll compare 23 with 23. I have got the corresponding output. 23 is the element. So it will divide it, binary, either 0 or 1, either left side or right side. So I will divide the array by 2, binary array by 2, and then I will compare with the element whether the data is in the left side or right side. So if it's in the right side, then I will change the L index to the median plus 1. If it's in the left side, then I will change the corresponding H value to the M minus 1. This is the logic behind the binary search. So now here set low is equal to 0. While low is equal to 0, I need a corresponding index. L is equal to 0 and H is equal to N minus 1. So why 10 inputs are there? So N minus 1, 9. So while low is greater than equal to high, that means that until equal to low is equal to high, I will keep on doing. So how do we find the mid value? Low plus high by 2. And then I'll be keep on comparing. If array of mid is equal to target, so if array of mid is equal to target, in our case it's not. Array of mid is 16 and target is 23. It's not. So I will go for a next case. If array of mid is lesser than the target. So array of mid is 16 is lesser than the target 23. 16 is lesser than 23. So then what happens over there? I will search in the right half. So I will search in the right half. So LO is equal to mid plus 1. And then in the second case, you can see here, if array of mid is greater than target. So array of mid is 56, which is greater than the target. So I will check in the left side. I will check in the left side. So I will change the h value to the m minus 1. So high is equal to mid minus 1. Then once again I will do the same until while low is equal to high. This is algorithm. So now you can see the programming. The same thing. While low is lesser than or equal to high, I will find the mid value, and then if mid is equal to key, I will find give back the corresponding mid index. If not, I'll comparing with the mid lesser than the key or not. Low value will be get changed. If mid is greater than the key, I will change the high value. This is the algorithm for the binary search. The binary search is nothing but it will divide the corresponding sorted array into 1 by 2, and then it will, for example, if I have n number of data, then I will search in the only the remaining 7. So 10. So remaining 5 I will be searching. In the remaining 5, I will search in the 2. In the remaining 2, I will search in the any one of them element will be there. So it will, best case going to be order of 1. So if the mid element is going to be an searching element, then it's in best case going to be order of 1, and the worst case going to be an order of log n, because we are dividing by 2. So it's an order of log n is the worst case. This is the binary search. Our next search is going to be a jump search. The jump search is all about when can we use it. Whenever the array is sorted, then we can use the jump search. So what are the steps to perform the jump search? So here the keyword is going to be step size. So now straight away we'll go to the example now here. This is the array. So this is the array means what happens over here? The inputs are, there are 1, 2, 3, 4, 5, 6, 7, 8 elements are there. N is equal to 8. So now for this n is equal to 8, I'll perform square root of 8. That's the first step. Step size is equal to square root of n, where n is equal to 8. Number 8 number of inputs are there. So square root of 8 is equal to 2. So now what do I do over here? So jump to 2. Okay. So now jump to 2 means what happens over here? Array of 2. This is 0, array of 1, array of 2. Array of 2 is 5. So 5. The target is 11. So 11 is greater than the 5. That means that I need to jump 2 more steps. So jump to 4. Okay. So array of 3, array of 4. So array of 4 is equal to 9, which is lesser than the target. Target is 11. So which is lesser than the target. So now jump to 6. So now what happens over here? So it will go over here. Array of 6 is equal to 13. So 13 is greater than the 11. That means that which is in between the 4 and 6. The data which I am searching for is between the 4 and 6. Then I'll perform the linear search from 4 to 6. So I will check for the array of 4, array of 5 and array of 6. And then in the array of 5, I'll get the data. So the jump search is nothing but it's a combination of your step plus linear search. That is a jump search. So now here we can see the example with the program. So now what I'm going to do it over here, this is a jump block and then this is the linear search block. So this is an and jump block and this is a linear block. So now here this is the corresponding index and array. There are 12 elements are there. Among the 12 elements which I'm going to search for the 18. I'm going to search for the 18 data. So now square root of 12 is going to be 3. Square root of 12 is going to be 3. So now what I'm going to do it over here. So initially step is equal to square root of n. The step is equal to 3. So then initially previous is equal to 0. Previous is a variable which I'm going to take and then we will see why do we require a previous variable. So then we'll come for the this jump block. So while array, so step is equal to 3. So it's 3 lesser than the n, which is what is the n? N is the 12 number of elements. So 3 is lesser than the 12. So then what do I do? If it's true, then array of step minus 1. So array of 3 minus 1, it's an array of 2. It's an array of 2. 2 is lesser than the key. So array of 2, you can check over here. So array of 2. So array of 2 is 6. 6 is lesser than the key. The key which I'm searching for is 18. So then what I'm going to do it over here, I will update the previous and step. So previous is equal to step. Step is 3. And then what happens over here? Step is step plus equal to square root of n. Nothing but step is equal to square root of n plus step. So 3 plus square root of n value is 3. That's the meaning of step plus equal to square root of n. Square root of n value is 3. 3 and then plus the same variable step. Step value is 3. So 3 plus 3 is 6. So next jump is going to be happen for 6. If previous is greater than or equal to n. So previous is 3 which is greater than the 12. So then what happens over here? I will go back once again here. So now here in this case, so now step is 6. Step is 6. 6 is lesser than the n. N is 12. Yeah, it's correct. It's true. Then what do we do? It will go for step. So array of 6 minus 1, array of 5. And the array of 5 is 12 is the data. So 12 is the data which is lesser than the 18. I'm 18 is the data which I'm searching for. 12 is lesser than 18. So then what do we do? Previous is equal to 6 and then step plus equal to. So 6 plus 3. 6 plus 3, it's 9. Step is be equal to 9. So then once again, previous is 6 is greater than the 12. It's correct. So go back once again, do it again. So now what happens over here? Step is 9. Step is 9. So 9 is lesser than the 12, correct? So step array of step minus 1. So now what happens over here? Now array of, yeah, array of 8. Array of 8. In the 8, we have data called an 18. We have data called an 18. So then it's lesser than the key. Yes, it's not equal to, right? It's lesser than the key. So now what happens over here? This condition gets failed. This condition gets failed because I'm searching for lesser than key, not lesser than equal to. So in the array of 8 only I have 18. I have a value called 18. So now what happens over here? This block gets failed. Then it will come over here. So previously I is equal to previous. That means that previous it was 6. Previous was 6. So from 6 onwards, it will perform linear search. So array of 6 is equal to key. No. Array of 7 is equal to key. No. Array of 8 is equal to key. Yes. Then it will return the I value. This is called jump search. The best case is going to be order of 1. In the first step itself, if you have found the data, it's order of 1. The worst case is going to be order of square root of n, because we are going to keep on performing the square root of n step until we go for the last data. So the worst case is going to be order of square root of n, and best case is going to be order of 1. And next is called interpolation search. The interpolation search is nothing but where you can apply the search. Whenever data is uniformly distributed, then you can apply this interpolation search. You can see here then the array is 10 uniform distributed, 20 plus 10 30 plus 10 40 plus 50. So now what happens over here? It's uniformly distributed. So now this is the formula. This is the formula for the interpolation search. So the corresponding low is equal to 0. The index 0, 1, 2, 3, 4. So low is 0. So 0 plus the target which I am searching for is 30. So 30 minus array of low. Array of low is the data. Array of 0 is 10 into high minus low. So high index is 4 and low index is 0. So 4 minus 0. So divided by array of high. Array of high is 50 data minus array of low is 10. It's a 10. So by if you apply this if you calculate this formula, the output will be 2. The output will be 2. So that the data which I'm searching for is in the second position. So array of 2 is equal to 30. So array of 2 is equal to 30. So this is an interpolation search where you can apply for data is uniformly distributed. So if the data is not uniformly distributed, then it is not useful. So these are the different searching algorithms which we have in data structures. So there are many algorithms are there. So these are the basic searching algorithms are there in the DSA. The first one is called linear search, where we will search the data one by one. Binary search, we will divide the sorted array into by 2 by 2 by 2. And then jump search is a combination of your square root plus linear search. And then where interpolation search is nothing but it's a formula based search where you can apply for the uniformly distributed data. Thank you for watching.